Thank you. Good afternoon. So as Ruth said, I'm Pito. I work at Deloitte Digital. But probably what's more important is actually what I believe in. And I believe that we are here on this planet to solve meaningful problems. And throughout our history, we as humans, we have built tools to overcome those challenges. And software, or software development, is one of those tools that we have built. However, you see, building good software is hard. It is hard because it is part science, it's part engineering, it's part art. It requires careful conjoining engineering practices with agile ways of working. It requires finding the right balance, or the delicate balance between building the right thing and building it well. And it requires passionate people. And this is what I do. I sit at the intersection of engineering and software development, between agile methods and building and working with high-performance teams. And I'm here today to learn some of my sharings with you. So I do apologize, I don't have the clicker. The USB port is used, so you cannot just lean over, so I apologize for that. But have you ever wondered why do projects fail? I did, and one of the conclusions I came to is because of a series of wrong decisions. And we make all sorts of decisions of who to hire, what to build, how to build, what to release, and so on and so forth. Tons of decisions. And we are under constant pressure to make decisions under the constraints of time and knowledge. We often don't really know the answer to the questions, but what we are asked to provide one. And we don't have time, indefinite time, to search for answers either. Yet, our managers, our peers, or our bosses, our colleagues are seeing us as having supernatural minds, possessing demonic reasons of power, boundless knowledge, and all the time in the world to make the decisions. And yet again, we know that it's important to make decisions. So it begs the question, how can we make good decisions fast? So the idea of this talk stemmed from two real-life experiences I had, which kind of led me to a path of reflection, a bit of research, and I found something which I'm here to share with you. In terms of structure of the talk, I'm going to introduce very briefly, I'm going to talk about visions of rationality, introducing heuristics, adaptive tools of heuristics, and because we're a software conference, I'm going to talk about the agile adaptive tools of heuristics. So we start with visions of rationality. According to George Renzi and the ABC Research Group, they argue that rationality comes in two forms. The first split separates models that assume the human mind have unlimited demonic and supernatural powers and capacities from those who behave or to operate under the constraints of bounded rationality. Two forms of demonic powers are unbounded rationality and optimization under constraints. They talk about making decisions by surveying all the alternatives, listing all the consequences, estimating the probabilities and utilities, and making the calculations. And they are traditionally modeled by probability theory. But you see, this is not how humans think and they reason. Simon Herbert, a Nobel Prize winning laureate, argues that models of human judgment should be made on what we actually know about the mind's capacities rather than fictitious competencies. These methods includes processes that largely negate the need for search for further information, fast and frequent heuristics that limit the space that we are searching for decision. Satisficing is a method for making a choice from a set of alternatives and consequentially when one does not know much about the possibilities ahead of time. Satisficing is evident in the behavior of firefighters, where in the life and their decisions, when in the heat of a fire, they need to make very quick decisions. And instead of surveying all alternatives, they pick one, they play quickly to a mental model, and if that's good enough, as it exceeds a predetermined level of success, they act without even looking for all alternatives. Building on satisfying, fast and frugal heuristics limit the search of objects and information using easily computable stopping rules and easily swappings, and make the choices using easily computable decision rules. Let me give you an example. When a patient is rushed to the hospital through a heart attack, a doctor has to make a decision to determine whether the patient is a risk or not a heart attack. Up to 19 cues are measured on admission. Common sense dictates that the best way to make a decision is to somehow take those 19 values that are measured and combining into a magic formula to derive to the solution or to answer. Consider in contrast this simple decision tree as 3 simple yes/no questions. It's fast because it doesn't require much computation, and it's frugal because it searches only or uses only on a subset of available information. Its simplicity, it raises suspicion that it is highly inaccurate. However, it is in fact a more accurate method of classifying heart attack patients than some more elaborate statistical classification methods. Even in a game of chess, when at any given time there is one best optimum move, in fact, given the type of the game, there is no strategy that can calculate that move in a reasonable amount of time. So the ABC research group, Gergi Gerenzi and Peter Todd, in their book Simple Heuristic Makes Us Smart, they propose a move from omniscient mind computing intricate probabilities and utilities to a mind reaching into a toolbox full with fast and frugal heuristics. And this is what I'm proposing as well. Let me very quickly take you through the terms of heuristic and how have been used throughout the history. So the term heuristic is Greek origin, meaning service to find out or discover. In early 1800s has been referred to a useful, even indispensable method for processing tough problems that cannot be handled by logic or by probability theory. In 1905, Albert Einstein, in an award-winning paper, he used a term to indicate that he considered the views within the paper as incomplete, false even, but still useful. He went on saying that a heuristic is an approach to a problem that is necessarily incomplete given the knowledge available, hence unavoidable false, but which is useful nonetheless for guiding thinking in appropriate directions. In 1920, the terms have been used as a useful shortcut, as an approximation or rule of thumb for guiding search. Close to our modern times, Dave Snowden, somebody who has shaped quite a lot my ways of thinking and creator of Kinevin framework, Welsh gentleman, he talks about heuristics as a ideal control mechanism under the conditions of uncertainty, and their general form is easy to understand. And he often uses this US Marine heuristic in his talks. And it goes like that. When the battlefield breaks down, capture the high ground, stay in touch, and keep moving. This is a heuristic to ensure that soldiers on the battlefield have autonomy to respond quickly to changing conditions, while remaining aligned to the stated commander's intent for the specific battle. Their compliance is easy to test, and they handle uncertainty. To test compliance is quite simple. You just have to ask a series of yes/no questions. How we captured the high ground, how we stayed in touch, how we kept moving. Let me give you some other examples. Formula One fun. I had to put one slide up as well. So Adrian Newey, probably one of the all-time greatest F1 designer, he had a heuristic, albeit he hasn't called it heuristic in his book. He says, continue to evolve the design of a F1 car unless, continue the design instead of starting from scratch unless you're clear on the wrong track or the regulations are changing. Into software development, Joel Spolsky, CEO of Stack Overflow, says, don't rewrite code since you're throwing away knowledge. You're throwing away years of knowledge that have been captured through bug fixes. He recommends to solve coding issues instead of carefully moving around by refactoring. Martin Fowler has a heuristic on coding in his book Refactoring. Says a heuristic we follow is that whenever we feel the need to comment something, we write a method instead. Just as a mechanic will pull various tools to fix your car instead of always hitting the hammer, different domain of thought requires different specialized tools. And Agile, as a domain, requires its own adaptive tools of heuristics. A toolbox of heuristics for making, I would say, reasonable decisions in software delivery. And at Deloitte Digital, we tend to have two toolboxes of heuristics that we give our practitioners. And one is process heuristics, and one is technical practice heuristics. One is about Agile and Lean toolbox, and the other one is about engineering and software development. Let me take you through them. Discover iteratively. You should accept that not all the work can or even should be defined up front. And you should allow or build work methods that allow for discovery and the solutions in an iterative fashion. And as Jeff Patton would say, if you're doing it only once, you're not iterating. Quite often in engagement, just the definition of iteration is a hard term to accept, because actually means is that if I've done something today, I might have to throw it away tomorrow. That psychologically doesn't really sit well with people. Create conditions for novel ideas to emerge, have coherent ideas, do prototyping, and have a real options mindset in mind. Build multidisciplinary teams. Create teams around a well-defined slice of work and give them all the means necessary to the work. Means knowledge, time, resources, which are power, computing power, books, and so on and so forth. Yeah. Build I know it's cheesy, but the psychological safety has to be built into the team. People have to feel safe unless they harm themselves or others and they break the law. They should be allowed to fail safely. They should be allowed to feel that if they have an idea, if it fails, it's not the end of the world. Yeah. It is quite difficult to introduce this, but good high-performance teams that I've been part of, and this is a real picture of a project, we did have this psychological safety where we're allowed to fail. And again, going back very quickly to compliance, easy to test, handle uncertainty, it's very easy to test. Have we discovered work in an iterative fashion? Yes or no. Have we built multidisciplinary teams? Yes or no. It's quite easy to test. Make sense of your world. Accept that when you're doing work, you're gonna deal with problems that are different from a complexity point of view. You're gonna be dealing with problems ranging from things you've done before, and it's only one way to do that, and you apply best practice, to things that are more complicated that maybe you haven't done it before, but maybe others have done it, where expertise or analysis can give you an answer. And in this space, you apply good practice, not best practice, it's good practice. You get multiple ways of doing that. To ranging to complex problems, where as a matter of fact, you don't know the solutions ahead of time. Yeah. And depending on what type of problems you're dealing with, it requires different methods and ways of working. And Cynefin is a framework, so that's a kind of quick drawing of Cynefin. Cynefin is a framework that allows you to understand or to build a language to understand the type of problem you're dealing with, and then behave accordingly to the problem you're solving. understand your landscape. So Simon Worley would say that execution alone is not enough. You also need a good strategy. And this is a Worley map. And if you haven't run into Worley maps yet, I would highly recommend Simon Worley. So it is the first step that you do to understand the landscape you're operating on. And whilst Simon described or came up with this framework for strategy, I have used this mechanism in day-to-day work. I've used this to map our scope so that we can make better decisions, for instance, how we split the teams, how we allocate the work, and so on and so forth. Design work system. Define a system that allows you to track and manage your work. Give a strong consideration to cube-based systems, such as Kanban, but also remember that not everything can be modeled through Kanban. But the good news is, most things we do can. So visualize, limit your work in progress, and manage your queues. Use an approach based on observation and measurement. So build your work system that you can measure, you can track. Measure flow metrics if you use Kanban, such as cycle time, work in progress, and throughput. Analyze those metrics and use them to build better work policies and go around the loop again. Yeah. Measure the flow and preserve the flow. Use forecasting approach to planning. So there are two ways to estimate. You can use a deterministic, well actually you can do no estimation at all. If you can get away with it, do it. But I never managed in 20 years to get away with that problem of when will it done. So you have kind of two broad options, is that to use a deterministic approach, which means that you provide one date that the project will be done on 20th of February, or use an approach similar to weather forecasting, where you offer a range of dates, a range of possibilities backed by probabilities. Yeah. It's much better, because the reality is, unless you're dealing with problems that you've solved before and just repeating yourself, quite unlikely that you can forecast accurately. And use the concept of forecasting, it enables us to send a message that actually may not know the answer. Set short feedback loops. So put feedback loops throughout your development cycle. Pair programming is a form of feedback loop. Having your releases broken down to smaller chunks and releasing them iteratively, it's a form of feedback loop. You take that feedback and build it and use it to improve your system. Retrospective, of course, is a form of feedback. So these are kind of the high-level heuristics that we use and kind of ways we can make it happen. And I'm going to move to technical practices heuristics. So we used to have our own kind of technical practices until this excellent book was published, the Accelerate book by Nicole, Jess, and Jean. And frankly, there was so much overlap between our toolbox and their practices that we have chose to adopt theirs. So most of them, if not all, are based on that brilliant book. So version control everything. Version control all the artifacts. That includes application code, application configurations, and system configurations. Look at infrastructure, having a mindset. Look at it from angle of infrastructure as code. Automate deployments. So computers are really good at repetitive tasks. Humans should use their mind to solve tough problems. And as Dan North would say, automating tasks become boring. So of course, aim to achieve zero downtime deployments, and look at the concepts such as environments on demand, which means that you as a team member, if you want an environment X, you should be able to just press a button and this environment should kind of pop up for you to do the work that you have planned to do. So integrate early and continuously. So you CI. CI is a process that creates built-in packages that are potentially shippable to production, and test early at higher states of integration. And the way you can always see it is if that blue cube would be a package that is potentially shippable, as you go through more test cycles, kind of have those concentric circles and you gain more confidence. And every build could potentially become a shippable product as long as it meets your quality criteria. The next one is my favorite. In our project, we have tons of fights, trunk-based development or non-trunk-based development. Since the book came out, and by the way, the book Accelerate is based on a DORA research. So based on research, it has been proven that trunk-based development is a predictor for high performance in software development delivery. So it is my favorite argument to pull out of the toolbox when we have these debates, what kind of branching strategy to use. But remember, we're still in a heuristic space, yeah? Sometimes it might work, sometimes not. But nevertheless, it's a great cheat sheet I'll use. Automate tests. As Cassie says, use test automation to cover your test processes. To sustain high pace of delivery, maintain the rigor around automation and test early, often, and hopefully well. Test data. Test data becomes ever so important in the space that moves towards continuous delivery. That data and test data shouldn't be a limiting factor of how much testing you can do. It is quite often in our clients and engagements where we are limited of how much data we can, how much data we have, and therefore how much testing we can do. Pay attention to test data management. Shift left on security. Integrate security into design, implementation, and testing processes. Make InfoSec as a team member, not somebody outside your team. Quite often, I see it where organizations say, yes, we have InfoSec part of a team, therefore, even physically, they actually sit outside the team, don't even sit in it. I find it, from my experience, it's quite difficult for security folks to join the software teams, especially in the kind of the modern development methods and tools we're using in the cloud, and they find it quite off-putting for them. But you have to bring them into the loop and use approved security libraries, and security testing should be part of automated test suite. And lastly, implement continuous delivery. And this is a practice where the software is in a deployable state throughout its lifecycle. And in here, you're going to have the battles between building new functionality, which always the client and business wants, versus keeping the software in a deployable state. Yeah. So that is not an easy balance to strike. But if you want to use continuous delivery, keeping the software in a deployable state, I would argue, is as important as building new features. And again, why continuous delivery is important? It's kind of same argument from the Accelerate book. Companies use continuous delivery have been proven to have to be high performing companies than others. Okay, so this is kind of the high level heuristics. Version control everything, automate deployments, and right to implement continuous delivery. This is what we do. This is our practitioner. We give them two toolboxes, one process, one heuristics, as we kind of cover them. We set them on the road, and we ask them to use them appropriately whenever they have to make decisions. And when I put together this talk, I didn't really know whether am I talking about principles or heuristics or rules. So I find this, again, going back to Dave Snowden, an excellent book, a blog he wrote, and there's a distinction between rules, principles, and heuristics. So I'm not quite confident I'm talking about heuristics, because rules, Dave says, that set limit to action, and they contain all possible instances of actions, whereas principles, many actions can be justified by interpreting a principle, and heuristics are a measurable guidance which can adapt to the unknowable unknowns. And we know, and this is an important element, is that a heuristic that sometimes will work, sometimes it doesn't. But should it fail, we should not be punished. So what was this talk about? Well, I hope it was a bit about software, about Agile, and a bit of cognition. And cognition, as I find this brilliant quote, is the art of focusing on relevant and deliberately ignoring the rest. And maybe we need to use this mindset more and more in our work. Yeah? So focusing on the relevant and deliberately ignoring the rest. Well, was this talk useful? As Einstein said, is that heuristics is unavoidably false, but is useful nonetheless for guiding thinking in appropriate directions. So I hope that I've given you something to think about. Maybe you're gonna apply the concept of heuristics in your work, and maybe you build your own heuristics in day-to-day. Thank you very much. If you have any questions, please raise your hands.
So you have slides that kind of said these are the 3 key questions to work out. Do you know, it's the medical slide, so like the whole concept of heuristics.
Yeah.
That seems like a really simple thing. Just find your heuristics. Well, how do you actually do that? Like, how do you find what is the key question, the key? That's the magic bit that you've got to work out.
It's a very good shout. I can just talk about the heuristics that we had, the process and the engineering ones. It is actually those simple heuristics. These ones. They're actually, in one hand, you can say your common sense, but on the other hand, there are things that we have kept developed in our organization and kind of synthesized. You can say, actually, that is relevant, stays, the other one doesn't. So you have to, I guess the hard part is to understand how to build your heuristics, and experience and knowledge and the kind of research is all part of it. And again, the engineering heuristics was again, our hours were coinciding so much with the Accelerated book that we chose to adapt theirs. Yeah. But indeed, I mean, and by the way, this is just a starting point. And again, is the point of it not to be dogmatic about it, yeah? And also understanding that the key thing is that we actually don't know always all the answers. And using rule of thumbs are a good way to come to an answer that sometimes works, sometimes doesn't.
How do you think this feeds into the debate then about is software engineering science or art? I mean, if you're finding heuristics and continuously looking for shortcuts and ways to, beat the loop, or that the whole loop is going to take too long, does that take us away from the kind of quest to bring more formal rigor to measurement and metrics and performance analysis and so on?
Okay, so the question is, if you use shortcuts, how do we balance that with rigor and metrics? Yeah. Well, I'll cheat. Well, it's easy for me to say because one of them is use observation and measurement. Yeah. So
you use rigorous methods as a heuristic.
So I mean,
skip it.
So it's quite. And actually, I'm really big into observation, measurement, and forecasting approaches. Some of the folks here we worked with maybe know this. So it is about actually, first of all, heuristic number 1, define a work system. Okay, and 2 would be then measure it and observe it, and then when you do that, the rigor of measurement should be there, right? But then if you find yourself that actually if doesn't give any results, then you shouldn't be really dogmatic about just pushing on with that one.
So be rigorous in measuring your heuristics.
I think being rigorous and using heuristics they're not contradicting each other.
Okay. Yeah. Right.
What's your take about examples or signs of cases where you better stay away from mindset, the heuristics mindset for finding a solution?
Yeah, so I'm aware of Daniel Kahneman's work primarily, and he wrote a book, Thinking Fast, Thinking Slow, where he would argue that heuristics are actually not a how should I put it, is they could lead to you to make wrong decisions. So I'm aware of that.
But you don't think so? You consider it a silver bullet?
Silver bullet? No, it's a heuristic. It cannot be silver bullet. But I would say that I would wait to see a better way of coming to better answers to cognition. So I do generally feel that they are a way to make decisions. It's part of your toolbox, the heuristics. Yeah. I'm aware of Daniel's work. He would argue otherwise, but my opinion is that should work.